Hello, my name is Ramin Hujjati and I will be giving a demo of the deadlock check in Solidify. Before you can run the auto checks in Solidify, you require a reset sequence. Fortunately, Solidify computes this reset sequence automatically during compilation. In this short presentation, I will not be able to cover all the capabilities of the deadlock check. There are four types of errors reported by the deadlock check: constant, stuck at, complex deadlock, and livelock, and we will be looking at each one of them using an example. The constant error happens when a variable takes the same value after reset. For example, here we have a state machine, and the state machine has 6 states, and the state values are encoded using 6-bit values. And as you can see, the leftmost 3 bits are always 0. So the code is presented in here, and we have a parameter that goes from 0 through 5. The state bits are 6-bit quantities as presented here. And what we're gonna get is that these two state bits have their leftmost 3 bits always be 0. So let's run the deadlock check. And it's running with low effort, and livelock is off. And you could see we're gonna get a report, and these two state bits always have their leftmost 3 bits being 0. Now, one of these is, of course, the sequential part, which is state, and then the other one is the next state value. Stuck at errors happen when a variable assumes a value and it never changes that unless reset is hit. So the example we'll be using is a counter that counts from 0 through 3, but then when it hits 3, it remains at 3. So in binary, we have the following sequence. And as you can see, from 0, we go to 1. And again, from 0, we go to 1. And also for the 1 bit, we go from 0 to 1. For the first bit, also, we go from 1 to 0. But once we assume the value 1 in the left bit, we never change that value. And that is what the stuck at fault is going to tell us, or the stuck at 1 is going to tell us. So we're going to run the deadlock check again, and you can see here's the code for it. And if the count is less than 3, we count up, so the last value that we reach is 3. And here you could see that we're getting that count is the leftmost bit of it is stuck at 1. The next type of error is the deadlock error, or sometimes we call it complex deadlock. And that is when in some state of the design, the value of a particular variable doesn't change unless reset is hit. So you could see once you hit S3, after that, no matter where you go, the value of the variable B never changes. So we will look at an example. And in this example, we have 2 counters. And the first counter counts up if the second counter is not 2. And the second counter counts up if the first counter is not 3. So in this case, the value 3.2 is a deadlock state. So let's look at the example. And here you could see this is the first counter, and it counts up unless the second counter is not 2. And you could see similarly, the second counter counts up unless the first counter is not 3. So the deadlock state is 3 and 2. So I'm going to run this one from the CLI just to show you how CLI works. I type in auto check deadlock, and then I don't need to say anything about the effort level because medium is the default effort level, and that's what we need for this example, medium effort level. So it runs, and this is the report that we're getting, and it is telling us that the value that deadlocks is count 1 being 3 and count 2 being 2. And it also tells us that it generated a debug trace for us. So if we open the debug trace, we will see that count 1, after reset, both counters are 0, and then count 1 goes to 1, 2, 3, and then count 2 goes from 1 to 2. And then this is the deadlock state. This first signal is where the problem occurs, and it's a Solidify generated a signal called property fail, and this is the error state. Now notice how Solidify intelligently chose values for up 1 and up 2 so that they reach this deadlock state. So for example, up to was 0 in here, and then they were 1 in all other cycles. Now let's go look at livelock. And livelock happens when the only transition out of a set of states is reset. So here the example that we have is a state machine, and the last 2 states of the state machine keeps repeating. So you go from state 0, 0 to 1, 1, or from 0 to 3, and then you go back and forth between 1 and 2. And as you can see, all bits keep changing in this cycle. So you go from 1 to 0, and then get from 0 to 1, and then in this bit you go from 0 to 1 and back from 1 to 0. So there's no deadlock here, but there is a livelock, and I will again show this through the CLI. And to turn on livelock check, we type in -livelock and give it the value 1. And I'm actually running it on the wrong one, so let's go back and running it on livelock. And what we should be getting is that 1 state is the livelock state, and that's exactly what we're getting. And again, Solidify is telling us that there is a debug trace, so let's open that debug trace. And here we notice that the state variable, when reset happens, goes to 0, and then it goes to 3, and then it goes to 1, and this 1 is the state where we livelock in. And you could see from the code that you go from 0 to 3 and from 3 to 1, and that's what the debug trace was showing us. And once you hit 1, then you go back and forth between 1 and 2. Now I'm going to show you another example of livelock, and the point of that one, is to show you assumptions. So this example is basically the same as the last example. It's coded a little differently, and it's coded such that we don't have dead codes or dead locks, but we do have a livelock. And again, you go from state 0 to state 3, and from state 3 to 1. And then this is the out state. If n is greater than 0, you go back and forth between states 1 and 2. But if n is equal to 0, then this statement takes over and you go to state 0. So you fall out of this cycle and you go back there, and therefore you won't have a livelock. So if we run the livelock check by recalling the command, you will see that we don't have a livelock, so we get no errors. Now I'm going to add a property file which I have prepared in PSL. You could use either SVA, PSL, or HPL property languages to specify your assumption. And this is a fairly simple assumption that is saying that input is not 0. And if we run the deadlock check again with this assumption on, now we have taken our out transition away. So as a result of that, then we get the same livelock that we had previously. This concludes my demonstration. Thank you for watching.